Hello, alright, I wanted to give you guys a little bit of a heads up on what we're gonna be working with a little bit more tomorrow. And so we've been talking about inverses, and kind of the main idea of inverses is that we switch the x value with the y value, right? So the x and the y, they flip-flop, so x becomes the y becomes the x. And so what we're going to do is we're going to take this idea one step further with algebra versus looking at it graphically. So remember, on a table, mainly what we did was we just switched our x and our y values. And really, truthfully, if I wanted to, I could take an x value here, like let's say 0, and if I plugged it in here for 4 over 3 times 0 plus 3, I would get 0 plus 3, and I know my y value is 3. And let's say I take another value of x, the value of, say, 9, and we do 4 over 3 times 9 plus 3. So this will be another version here. So 4 times 9 gives me, remember, it's always divided by 1. So 4 times 9 gives me 36, and 3 times 1 gives me 3, plus 3. And 36 divided by 3 gives me 12, plus 3, which gives me a total of 15. And so I'm going to take just these 2 points here, and we're going to leave them here on the side, okay? So as we look at this algebraically, we're going to come back to this table. So I'm going to label this table my f of x, all right? Otherwise my original function. And so then we're going to come back to the actual equation that we have here. And we know that if we wanted to find the inverse function, say the, let me erase a little bit here. Let's say and we use this little prime symbol here for the word inverse. And so I know that if I wanted to just use the inverse of these points, it would be 3, 0, and 15, 9. There we go, 15. So let's go ahead and look at the equation that we have here. And so remember, the main idea is that I switch the x value with the y value and the y value with the x value. So to do the inverse, to start the inverse, I'm going to just rewrite my problem, but with the x and the y switched. And so all I have to do then is just solve everything for the y variable again. And so if you guys remember your order of operations, PEMDAS, whenever we solve a problem, we work PEMDAS backwards, so this way. So the first thing I want to look, is there anything I can add or subtract from this problem? So I go minus 3 and minus 3. Remember, I have to jump over my equal sign in order for me to do this. So these two cancel out, and I'm left with x minus 3 equals 4 over 3y. Now, here at this point, so there's nothing left to add or subtract, and I'm looking at the multiplication and division now at this point. And remember, my end result, I want to get this value to be just y equals, right? And so the magic number, or the invisible ghost number in front of the y, is 1. And so what I have to do is I have to find a number that I can multiply this by, the 4 over 3, in order for it to get to the number 1. And the easiest way to do that is just to multiply by the reciprocal. And so, 3 over 4. So when I do that, I end up with 4 times 3, which gives me 12, and then 3 times 4, which also gives me 12, which 12 divided by 12 gives me the number 1 that I was looking for. So now let's go over to the other side here. So I have, remember, this gets multiplied into both objects. So 3 times x is 3x. And remember, the x is always divided by 1, and same with the 3. So 4 times 1 is 4, minus 3 times 3 is 9, divided by 4. And so my final value here is this. But we can take this one step further because I know that the denominators are both the same. So I can rewrite this to make it look a little neater. The common denominator that we have, and we put both of those down here, 4. And I just take the numerator. So we have 3x minus 9. And all of that is equal to the inverse of y. And I put this little prime to show that this equation is the inverse of the original equation. And so coming back to our table that we had here, we can actually test to see if we did have an inverse or not. Because remember, if I plug in 3 now in here for the x, I'm supposed to get the number 0 out of this. So let's go ahead and try that out. And we'll do it here in red. So we have 3 times 3 minus 9 divided by 4, which gives me 9 minus 9 divided by 4, which gives me 0 divided by 4. And what is the value of 0 divided by 4? 0. So this one checked out. So let's go ahead and try the next one. Alright, so 3 times the next x value that I'm looking at is 15. So 15 minus 9 divided by 4. So 3 times 15 is 45 minus 9 divided by 4. And so 45 minus 9 gives me 36 divided by 4. In my head, not so quick and easy here. Let's see. I know both divide by 2, so that will give me 1, which will leave me with 16. 16 is 8. 8 divided by 2 is 9. And so since I have this value of 9, this checked out okay. And so I know that the value that I got from my inverse, or the equation that I got from my inverse, really is the inverse equation of the original. So, alright. Let me erase this, and let's go ahead and talk about the next problem. Alright, so lastly, we come up here, and the main reason I wanted to do this is because we're going to talk a little bit about quadratics. There's some things in here I'm not going to go into too much detail about, but we will talk more about it when we talk about actual quadratics as a unit. So again, what I want to do here is just switch the x value with the y value. So I start off with y minus 2 squared plus 4. And remember, I'm going to write PEMDAS over here on the side just so we can kind of see why I'm doing things in the order that I'm doing them. And so remember, I want to start by looking at any addition and subtraction that I might have before I actually go up the ladder. And remember, the very top of the ladder now is parentheses. So any addition and subtraction inside the parentheses is actually the last thing I'm going to do in this situation. So since I have this plus 4 here, I got the adding and subtracting happening. So I'm going to do minus 4, minus 4. And I get x minus 4 equals y minus 2 squared. And now as I look, do I see any multiplying or dividing happening in here? And the answer to that is no, so I go ahead and cross those off. And the next one that I look at is exponent. I do have an exponent, and that is the squared here. Now, the opposite of a square is its square root. So when I do this, and this is the part that we're going to kind of just accept as fact at the moment until we get deeper into quadratics, is that since the opposite of a square is a square root, I can take the square root of both sides, and I'm going to put a plus or a minus. Anytime I take the square root of something, I put a plus or minus, meaning I'm doing the positive version and the negative version of both pieces. And so the square root of y minus 2 squared, this cancels that. And so what I'm left with is plus or minus the square root of x minus 4 equals y minus 2. And so now that I'm done with the exponent, the parentheses drop off and I come back down and start from the beginning. Is there any addition or subtraction that I need to do? Yes, and so I do the addition here. Plus 2 plus 2. Now, I want to make sure that we understand that since this 4 is underneath the square root, it belongs under the square root. This is not under the square root, so it cannot join the 4. So plus or minus the square root of x minus 4 plus 2. Inside the parentheses, outside the parentheses. And so just to kind of reiterate our transformations from last time, this shifted right 2 units, or no, 4 units, I'm sorry, and then shifted up 2 units because of this guy being on the outside like that. And so you can double check your answers to see if you have an inverse function in your calculator using your table function. You can put both this equation and this equation in your y equals and write out a table for yourself and double check and make sure that you have the inverse properties.